Hi everyone, my name is Max, and today on our Golang tutorial video we will be solving a very simple problem to create a one-page website that is built on Go and deployed on publicly available server so everyone can reach this one-page website hitting the IP address directly. This is just a very simple example of how to use Go for a very simple task. Usually if you have to build a website, HTML and CSS stuff, then Golang wouldn't be the best solution probably, but for the sake of exploring the possibilities of Golang, we will take this example. So what we're gonna do is that we will build locally the Golang program that will run a web server, be listening the 8080 port, and when you open this page, it will show the content of some HTML page that we will make very simple one. Okay, so let's start. We will start with creating the folder for our project. Let's create a simple website folder. Then we will initialize a Go module in this folder. So what is Go module is it's a new way to manage dependencies. And in my opinion, if today you start any project or any program on Go, it's the best way to actually start it because it gives you much more flexibility in terms of the package versions that you need to use, dependencies, and also flexibility where do you actually keep your Golang application. Before, the Go modules were created by the Golang development team. You had so-called Go path, which was defining where all the dependencies are basically stored. But with Go module, you can create a project in any folder on your computer, any folder in the system, your file system, and then in the folder you just type you just type go mod init, and then you type the name of the project. The best way to name your project is following this convention of where it's actually stored. For example, if it's a GitHub, then it will be github.com/your username/project name. For example, in our case, it's a simple website. By the time when you initialize the Go mod, you don't actually need to have this project to be on GitHub, and you can actually skip completely that and never post it and publish it on the GitHub. But for the sake of example and to follow their common, I would say, practice, we will keep this naming as is. Okay, so we initialized our project Go mod in this folder. Now we can see that when we initialized the project, we have Go mod file. What we have in this file is basically all the dependencies and the general information what version of Go this project is using. And now we can see that this project is using Go version 1.13. So whenever, for example, new version of Go will be released at some point of time, maybe 2.0, when you will be building this project, you actually tell the compiler that this project is built on the Go version 1.13. Okay, so we have the folder, we have only one file, go.mod, for our modules in it, and now we will create the first file, which is main.go. Let's just define the package name. We'll define func main. So if you're familiar with the basics of Go, you know that this is the least you need to do in order to build a very simple Go binary. So after this is done, we can run go build, and our simple website binary will be sitting just here. It doesn't do anything because basically in our main.go file we don't have any instructions. We have only function main, which is called when you run your application, but doesn't do anything. But it's good for start. Okay, now let's switch to a more user-friendly editor. I'm using Visual Studio Code. I think it's very simple and quite versatile IDE to manage your projects. So yeah, this is pretty much today the default editor that I'm using with all my projects. Okay, this is our project. This is our main Go file, and what we have here is basically the function main that doesn't do yet anything. Let's make some very simple instruction to print hello world. So when you click save, the Visual Studio Code will identify all the dependencies that you have in this project. For example, we referring now to the standard package FMT, which gives you an option to print something to the terminal. So once you refer to the function of this package, IDE Visual Studio Code automatically added it as an import package, because all the packages that you use in your program, they need to be imported. So in this case we got this one. Let's use the terminal right in the Visual Studio Code. So we have here our project folder, and let's build our project now. Once the project is built, we can run it and we can see that our hello world is printed right here. Again, it's very simple, basically one line of code Go program that is printing hello world. Okay, what do we do next? So we need to build a small website that will be running on some port that we select, for example 8080, and once you open this website, basically you send in the get HTTP request to this address and port. Then you will see the content of some HTML page. For the sake of example, let's create very simple index HTML page, which will be sitting right here, and we will serve this page to the client when they hit our website address by the port and the port that we specify. So for example, let's here we will make very simple HTML page with the hello world. So this is our HTML page. Okay, now how we actually start the web server and how we read the file and show it to the client, basically sending back the content of the file. In order to start the web server, we will use the standard package net HTTP which has ability to run a server. So we have this function listen and serve, which actually will run the web server and will be listening to the HTTP request on the specified port. For example, in our case it will be 8080. I forgot something. Yeah, okay. We need also to pass the handler to this function. The handler is basically what will be called when anyone reaching the address of our website on the port that we specify here. Handlers are basically will provide all the functionality of your website. In order to create handlers, I wonder if it will work, if we will pass nil handler for now. We will build our application. Yeah, it works. So for example, now we have a web service that is running on port 8080, but all the requests that come into this address and this port will not be processed because we didn't add any handlers. We didn't add anything that will process the actual HTTP requests. Okay, so now we can hit our localhost 8080 port and to see that our request is not actually processed because we don't have any handlers there. And if we open the terminal, for example, and we will curl our localhost 8080, we will see the page is not found because nothing is actually listening, nothing is actually processing our requests. Okay, so now let's add a handler that will process the HTTP calls and read the index.html file and serve the content of that file back to the requester, back to the client. In order to do this, we need to add our handler, and we need to specify which endpoint will it actually listen to. So in our case, we will be using the root path, meaning whoever sending the request to the root path of our website, that request will be processed by our hello world handler function. This function we will define here, and this function is accepting two interfaces. First is a response writer, and another one is HTTP request. So what stands behind of these two parameters? So basically, response writer's interface provides us an option to actually write the response to the client, write the response to the HTTP request that we get. And HTTP request is basically all the information about the request that we got from the client. So these are two variables that we need to actually process the request, get the data, transform the data if we need, and write the data to back to the client, to the HTTP response writer. And we will now check how to do that. Now we will be writing this response directly to our response writer interface. So in response writer we have function that's called writer. Right. So we will be passing in this function our hello world string, and this is basically the okay, we're missing something. So we have response writer, we have request, and it says that it cannot use the hello handler because the request should be parameter passed by the pointer, not by the value. So now we modify our function to have the response writer and the request as a pointer. So this function can be as an argument to the handle function, because this is basically the signature of the function that it expects from us. Now we're trying to build a program. We have our program built successfully. We're running our program and we go back to our browser. We refresh the page and we see here hello world written just here. So this is a very simple example of how we can run a web service, a web server on specified port that serves, in this case, just a string hello world. But our original goal was to basically read the file and serve the content of the file to the request. To read the file, the easiest way in Golang is to use the package io util, which has read file function, which will just read all the content from the file and send us back as an array of bytes. In this case, we know that the file that we're trying to read is index.html file. It's right here in our project directory. So we can specify just the name of the file, as we understand, assuming that we are running our program from the same directory where the file is. So in this case, as a return parameters, we have array of bytes and the error. So here we have content bytes and we have error. The error ideally needs to be properly handled. If something goes wrong, the file is not there, or the file is not accessible, or anything like that, we need to handle that properly. But for now, as it's our draft project, we will just panic, we will terminate the execution of the program, and we will print the error message into the terminal with all the traces. So we have our content bytes, and since the write function also accepts bytes, we don't need to transform our string to bytes. We will just pass our bytes that we just read from the function, from the file, using the read file function into the response writer write function. So basically we took everything from our file and we write it back to the client. We're building our program, we're running our program, we're refreshing our page, and we see here hello world. So this hello world already is not just a string, it's taken from the file that we have here in our project, which is index.html. So if, for example, we adding here now something else, some subtitle, we're saving this file. When we refresh, we have updated data here. We already have our hello world, and we added just now subtitle. So we don't refresh our program, it's running, and we just updating our page with the new content. We're refreshing our page here and we see the results. So this is a simple website that we built on Go that serves the request to a specified port. In our case it's 8080 on our local machine, and respond with the content from the index.html file that has some HTML here. Okay, now usually when you build the web applications, you want them to be available not only on your local machine, but you want them also to be available publicly. So now this program works perfectly fine on our local machine, on our local computer, but it's not available to anyone from outside. So what we need to do now is basically to deploy this application, which will be available for anyone to actually access and get this file, get this content online. So what I recommend to do, especially for the projects on earlier stages, or if you just want to play with something, is to use DigitalOcean as a hosting provider, because it's first very cheap and it's very easy to set up, very easy to use for simple projects which do not require too much of availability, too much of reliability. Okay, we need to create our DigitalOcean account, and let's create some simple account. I will use some of the credentials for this account, and it will be our playground, so you can create there your account as well. And I will confirm my account now on DigitalOcean. So you add your credit card information. It's not yet built for anything until you will actually create something inside your account. In our case, what we want to do is to create a new droplet. Droplet is basically a virtual server that we will be using to host our Golang application. We will pick the cheapest option that they have, because we don't need anything fancy for our very simple application. $5 a month will be good enough to run our very simple website, and to show how actually we can easily deploy our binary code to the web server and run it there right away. So I choose $5 a month droplet. I choose default Ubuntu server, which is good enough for our example. By default it says me San Francisco. Data center, I can pick New York because I'm from New York. Maybe it will be a little bit faster, but again, in our case it doesn't make much of a difference. Now authentication, you can use SSH keys, you can use one-time password. For this example, to make it easier, I will be using the one-time password to access the console of the hosting. Here it generated some name, which is all fine with me. Everything is good, so we will create our droplet. We will wait a couple of seconds while the droplet will be created, and right from there we will be able to access our newly created web server, and we will deploy our application on the web server. Nice, we have it done. This is how easy and fast to create a new hosting and new web server on the DigitalOcean hosting. Now we have IP address that is assigned to our server. We will copy this IP address, and also we will have our password sent to the email for the root user for this hosting. So what we will do now is we will go to our terminal and we will type SSH root at this address. Basically it's saying that we want to access the terminal on this server, on this address, using the name root. Root is a default administrative account created together with the server itself, so we can use it to set up the server and make sure that our program will be running nice. So on my first login into the server, it's asking me to create a new password for that. So for the sake of example, using the same password with the 123 in the end. 123 is end here. Now if I will exit this session, I will enter again. It will ask me the password. I enter the password here. So right away we are inside our newly created web server. Now, how we can ship our program to this newly created Unix server? So let's start with a very simple, just have it to work solution. We will use so-called scp command that will copy the local files into this server. So we need to first exit our session on the remote server, and being here on our local server, we will use scp. Then we tell what file do we want actually to send to our Unix server. In this case, we have our binary, which is called simple website. So we take our simple website and we say that we want to copy it to this. We want to copy it to the server, which is identified by this IP address. We hit enter and we need to specify where do we want it to be copied. So we want to place this file under the folder root. For this example it works fine, but in a production ready environment you don't want to store your binaries under the root user. You want to store them under another user that you create with very limited access, just for the sake of security. But for now we don't care about that, and we just want to have our simple small web service running on the remote server. Okay, now we got this request for password. We entered our password. The binary itself is being transferred to the remote server. So now we have our copy of the file there. We can again get to the terminal of that server. We can list the files that we have under the root directory, and we can see here that we have our simple website binary there on the remote server. Let's try to run it. We're running our server and we have the error. This error saying is that execution format error. It cannot execute this binary file on this machine, on the remote machine. Why is it happening? Because currently I'm working on the laptop which has Mac OS. It's a Unix system, but it's different from the Ubuntu. So we need to actually compile our program into the Linux compatible format. And Go has a command for that, and let's check how to do that. So we exiting our session on the remote system. We will clean a little bit our terminal window, and now we will use a command that let you to compile your file into the Linux compatible format. We'll be using the command go build again, but before running go build we will set the environment variable go OS Linux and go arc AMD64, meaning that the go build command will compile our program with Linux AMD64 compatible mode. Doing this, we compile our local binary in the format that will be running on the Unix, on our remote Unix machine. Now, if I want to run this file, this binary, on my local computer, I cannot do this because it's compiled in a format that is suitable for Linux AMD64, which my computer has OS X, it's a Macintosh, which is not compatible with this binary. So what we do now is we're running the same command to copy now our simple website binary to the remote host. We do all the same operations, entering the password, and we're waiting while it will be copied. It's done. Now we will go again to the remote server that we have, and we will try to run this binary again. We have simple website. Now I'm running it again, and voila, it works. Now let's try to access this file from our remote hosting, hitting directly the IP address of that hosting and specifying the port that our web service is running. The port is 8080. We're trying to open it, and what it says this page isn't working. Wow. Now we go back to our terminal and we see here that something bad happened. What happened here? You can see that our program has an error message, a panic, serving the request with information that it was not able to open index.html file, no such file or directory. Well, yeah, because if we will check the folder that we are in, we can see that there is no actually file index.html which we forgot to copy when we were copying our binary file here. And this is exactly what we told our program to do when we were writing the error handler. So we see that we have here, if error happens, then what we do is panic with the error message. Panic will terminate the execution of the program and will write out all the trace, what happened there, what message did we get, and everything. But unfortunately, this way of handling the error message is not very efficient for the client, because the client sees that the page just doesn't work. It doesn't provide any additional information. Let's improve a little bit our program to have a little bit better handler for our error message. For example, what we will have now is we will write to our client that, for example, the index.html file is not found, just for the sake of example, and we will return from execution. Now what we need to do is the same. We need to build our program in our server compatible mode, which is Linux AMD64. We copy our binary to the remote server that we have. Once we copied it, we can log in again to our server. We can run again our application. We can refresh the page, and we can see that instead of the generic error message, we have now the message that the index.html file is not found. So we made sure that our error handler works fine. But let's now basically copy our index.html file to the remote hosting. So I will copy it as index.html, and I will copy again the binary from my computer to the remote computer, so our program will be running smooth. Okay, so we copied our binary to the remote computer now. Now we'll log in again to our remote computer. Now we will run our simple website, and we will refresh the page, and we will see our hello world and subtitle, basically the content that we put into our HTML file. So this way, in a couple of minutes, we got our website running on a publicly accessible web hosting by this address with this port that serves our file, and basically anyone can reach that. What improvements can we have in order to basically streamline our process of deploying this very simple application? So one of the things that we can do is, first, if you're running a very small project, like extremely small application, and you don't need to do like continuous deployment, continuous integration and everything like that, what I used to do before is just to create a simple bash file. For example, deploy.sh, where I will put all the commands that I need to build my program and to copy it to the remote server. We have two files that we need to copy. It's index.html and it's simple website. Binary. So once we have this simple deploy.sh file, we can basically run it as bash deploy.sh. What it will do, it will run all the commands for us to build the application and to copy it to the remote server. The only inconvenience here is that if you have a password protected access to your remote terminal, then it will always ask you for this password every time it will copy the file. There are ways how to improve that. You can set up a certificate-based access, meaning that if you have a certificate that you generated on that machine locally, then that machine, the remote terminal, will recognize your computer and will let you access to it without entering any passwords, which is also one of the ways how to speed up the deployment using the scp command when you just copy the binary from your computer to the remote computer. But what's the problem that we have here? The problem is that, for example, now when we disconnect it from the remote computer, we refreshing the access to this page, we're refreshing this page and we don't see any content here anymore. So what happened is, basically, as soon as we disconnected from the remote terminal, the session is terminated, meaning that this terminal session is not running anymore, so as your binary. So as long as we are running the binary here in the terminal session, we can reach our website. But if we terminating the access, terminating the program, and we exiting from the session, our website is not running anymore. So what we need to do, we need to actually make our binary, make our program always running on the remote machine on the background. So we don't need to actually access the remote computer and run the binary to have our web service available all the time. So for that purpose, we have two solutions. And solution number one, which is much easier, is to use a tmux for having our binary running in the background. It's very simple because tmux is a tool that you have by default on your remote Ubuntu server. So you basically type in tmux, and this command opens the tmux itself. So from here we can, the same way we can run our binary, and instead of terminating the session with tmux, we can just hide it. So for example, in this case it will be Control B plus D command. So it's Control plus B plus D. Once you click that, the terminal, the tmux session will be still there on the background running with your program, but you can terminate the session with a remote computer and your website will be still accessible. This is one of the ways of how to solve it very easy and fast. But the problem of this solution is that if in case your program shut down for some reason, like something happened, your server got restarted, for example, by the hosting provider, or something happened and you have a panic in your program and you don't handle it properly, so the program just exits, it will not automatically restart the service. So you will need to go, for example, again, to connect to your server, you will need to connect to tmux, you will need to connect to tmux. You will need to open this session when your program is running and run it again, for example, which is definitely not acceptable for critical web services which needs to be running forever. But in case of a small project or very small service and you don't want to set up a complicated daemon service on your Ubuntu server, this works pretty much fine. Up until now I have some of the projects that I made years ago that are running perfectly fine on tmux without any daemons or services set up on them. So yeah, this is how you can solve this problem very fast and easy if you need something to be just working now. Okay, so this is pretty much all what I wanted to cover in this tutorial video. I will be focusing more on some more specific and detailed questions about how to run your service in production, how to set up a daemon service, so your application is basically being restarted every time when it shuts down or when the server is rebooting or something happens. Then also, yeah, next videos will be more about, I think, some specific Go tools and patterns or on Go language. So stay tuned and subscribe to my channel if you like that.